All right, welcome to This Explainer. Today we are diving headfirst into literally the most pressing question of our time. Is artificial intelligence going to replace us? I am so thrilled to guide you through this because we're going to look right past the hype, ignore the wild headlines, and skip the science fiction entirely. Instead, we're getting under the hood. We're going to break down exactly how this technology actually works. And you know what? Once you understand the mechanics of AI, you're going to see exactly why the future of work looks a whole lot different than those doom and gloom scenarios you've probably been hearing about. So today we're breaking this massive topic down into 6 clear parts. We've got 1. The great AI job question. 2. Decoding the AI alphabet. 3. Inside the neural network. 4. The generative AI revolution. 5. Hardware powering the magic. And finally, 6. Co-pilots, not replacements. Okay, let's jump right into section 1, the great AI job question, and separate fact from fiction in the workforce. We really have to address the elephant in the room here. Will AI take my job? It is the primary concern for so many of us right now. Just this lingering, heavy anxiety of total job displacement by machines. Whether you're a programmer, a writer, an analyst, or an administrator, you've probably opened a tool like ChatGPT and thought, man, how long until that thing can do exactly what I do, but way faster and a lot cheaper? It is a totally valid question, but to answer it accurately, we really have to separate the widespread myth from the actual technical reality. See, the common myth out there is that AI is just going to wholesale replace entire professions overnight. But the reality? It's all about task-based automation. AI rarely, if ever, just swallows a whole job whole. Instead, it automates very specific, repetitive tasks within that job. It's absolutely brilliant at things like writing basic boilerplate code, sorting through massive, messy datasets, and generating standard administrative reports. So, by taking on all that predictable grunt work, AI actually acts as a tool to augment your work. And for the people who choose to adopt it, it's leading to some truly massive productivity gains. To really understand why it automates specific tasks rather than wiping out complex human roles entirely, let's move to section 2 and decode the AI alphabet: AI, ML, and DL. Simply put, artificial intelligence is really just an overarching umbrella term. It basically means we're enabling computers to mimic human behavior. But the massive paradigm shift here is that modern AI does this by learning from data, rather than just blindly following rigid, pre-programmed rules. It's a huge category, so to truly grasp how it works, we need to look a little closer at what sits right beneath it. The best way to think about these concepts is like a set of nested Russian dolls. AI is that big, broad, top-level doll. You open that up, and inside you find machine learning, which is a specific subset of algorithms designed to learn and improve from data over time. And then you open that one up, and you find the deepest subset, deep learning. Deep learning uses these incredibly complex structures called neural networks, which are actually loosely inspired by the human brain. And these networks are what do the really heavy lifting for things like natural language processing and computer vision. To really appreciate how far we've come, we have to look back for a second. For decades, the field relied on what's called symbolic AI. This basically meant programmers had to painstakingly write out these rigid, fragile, if this, then that rules for every single possible scenario. It was brittle. It completely fell apart when faced with the messiness of the real world. Today, though, we've fully transitioned to connectionist AI, which includes those neural networks we just talked about. Connectionist AI doesn't need explicit hand-coded rules. It just ingests massive amounts of data, finds the patterns itself, and adapts on the fly. So, how do these modern connectionist systems actually pull that off? Let's get into section 3, inside the neural network, to see how machines actually learn. Every single AI system fundamentally follows this highly logical 5-step pipeline. First up is the input, where it gathers raw data. Next is the processing stage, where the AI sorts through that data and tries to decipher patterns. That leads to step 3, outcomes, where it actually makes a prediction, like guessing if something's a match or a fail. But step 4, that is where the actual magic happens, adjustments. When the AI inevitably makes a mistake, it learns from it. It adjusts its own internal rules before moving on to step 5, making its final assessments. We really need to zoom in on that adjustment phase because it relies on a totally crucial process called backpropagation. When an AI model spits out a guess, the system immediately measures exactly how far off that guess was from the right answer. Then it literally works backward through the neural network, tweaking and adjusting its internal parameters, or weights, to make sure that specific error is smaller the next time around. Honestly, it's exactly like practicing throwing darts. You throw a dart, it hits the wall instead of the dartboard, your brain instantly calculates the error, and you adjust your throw until you finally nail the bullseye. All right, let's explore how this foundational dart throwing, pattern matching kind of learning fuels the incredible tools you're using right now. This is section 4, the generative AI revolution, looking at LLMs and RLHF. So, you've definitely heard of large language models, or LLMs. This is the underlying tech behind heavyweights like ChatGPT and Google Gemini. But here's the crazy, mind-blowing part about all of this. These generative AI tools aren't actually thinking in the way you and I do. Not at all. They are quite literally just mathematically predicting the most likely next word or token in a sequence. And they do this based on billions and billions of text examples they've ingested. It is pure statistical pattern matching, just executed at a truly massive scale. But if it's just predicting the next word based on cold, hard math, how in the world does it sound so incredibly conversational? Well, to stop these models from sounding like dry, robotic encyclopedias, developers use an amazing technique called RLHF, which stands for Reinforcement Learning from Human Feedback. Basically, the AI generates a bunch of different responses, and real human raters step in and literally score them for things like quality, friendliness, and helpfulness. From there, a separate reward model is built from those scores. This trains the AI to optimize its outputs to perfectly align with what real humans actually prefer to read. Just look at the difference this RLHF tuning actually makes. If you ask an untuned AI model for the weather, you're going to get that first response. It's technically correct, sure, but it's totally robotic. But after RLHF tuning, the model learns to give you that second response. It's warm, it's conversational, it even adds helpful contexts, like the air might seem thicker. It just feels dramatically more natural and genuinely helpful to a human user. Of course, absolutely none of this mathematical magic, backpropagation, or massive data processing happens without some incredibly serious horsepower. Which brings us to Section 5, Hardware Powering the Magic, focusing on AI chips. Here's the thing. You cannot run modern deep learning on a standard computer chip. It completely relies on highly specialized AI chips, mostly GPUs, but also FPGAs and ASICs. Why? Because these specific chips are purpose-built for something called parallel processing. Instead of doing one really complex calculation at a time, like a normal CPU, they can perform millions of simpler calculations simultaneously. Think of it like this. Would you rather have one single super-fast master chef in a kitchen or 10,000 average cooks all chopping vegetables at the exact same time? For training neural networks and chewing through massive data sets, you absolutely need the 10,000 cooks. The wildest part of all this is that the foundational ideas for AI were actually dreamed up way back in the 1950s. But the industry went through several massive funding collapses, known as AI winters, purely because the computing power just wasn't there to actually make the theories work. It wasn't until around 2012 that a huge hardware breakthrough, utilizing those powerful GPUs we just talked about, finally allowed deep learning to just boom exponentially. That hardware shift is what led directly to the AI revolution we are all living through right now. Let's pull all of this technical reality together in our final section. Section 6, Co-pilots, not replacements. We're going to look at the human moat and finally answer our original question. So we've learned that AI is, fundamentally, a really advanced pattern matching machine. It predicts the next word or sorts data based on complex statistics. It is undeniably powerful, but it doesn't actually know or understand anything. That's exactly why it can so confidently make things up, a quirk we call a hallucination. Because of these limitations, certain traits form what we call a uniquely human moat. Skills like true strategic thinking, deep emotional intelligence, nuanced ethical judgment, and complex system design, those simply cannot be automated by a statistical model. They remain fiercely, permanently human-centric. And that brings us to the most crucial point to take away from this entire explainer. AI is here to handle your predictable coding. It's here for your repetitive data sorting and your mundane administrative reporting. It is stepping in as an incredibly capable co-pilot to wildly boost your productivity. It's designed to augment your capabilities and take the grunt work off your plate, not to eliminate your role entirely. The modern workforce is undergoing a massive seismic shift right now. We are rapidly moving from a world where humans are just the manual doers of repetitive tasks to a world where humans act as these strategic managers and orchestrators of these incredibly powerful AI systems. The tools are here, the hardware is more than ready, and the patterns have been learned. So my final question to you is this. Rather than fearing replacement, how are you going to step up, harness this technology, and make yourself completely irreplaceable?